Hello and welcome to the Test Tube podcast. I'm your host Dan.
Heyo, my name is Eric. We are representing Exeter in iGEM, the biggest synthetic biology competition in the world.
We are here to interview fantastic researchers and demystify the world of synthetic biology. Let's get right into it.
Woohoo!
Welcome to Test Tube podcast.
This week we have some questions that we're going to go through before we get into the actual interview. So we had a question from our Instagram. Could you go through the steps of iGEM? Like what your timeline for the summer is looking like, please. Of course. So iGEM is fantastic in that it's student-led. So to start with, as students we all collected and we had to come up with an idea. So what we did for the first week is we split into smaller groups and we discussed different ideas. So we had multiple ideas, one of which was our lovely spider silk idea. What we did is we moved on after presenting to academics and we decided the best course of action was the current project we're on. We then took that project and we began looking at prelims. So we understood what we needed to do was we needed to produce this spider silk in E. coli, and we understood that we needed to start working with graphene. And the earlier we could do both of those, the better. But you can't start working with synthetic silk until you start making it. So we needed to make the DNA. So what we had to do is design plasmids. So we looked at previous work, including academic papers, as well as previous iGEM teams, like the Great Bay. What we then did is build these plasmids through our designs with the help of our lovely PI Chloe, and we then moved on to order those. But we need to do prelims with graphene. You can't do that until you have your silk. So we decided to work with already made silk. That's right, we ran around the University of Exeter's campus collecting silk from unoccupied spiders' webs and began combining them with graphene. In the future, we're continuing with lab work. We've now got our DNA in, so we're working with that. And the idea is to continue lab work and hopefully continue producing good results. Throughout the summer as well, you have to do many things like working with stakeholders, messaging out companies, asking them their opinions, which has massively informed our project, leading us towards brilliant new goals and brilliant ways to test our product. Of course, as we continue on, we're going to continue working on speaking to stakeholders, always making sure to integrate it into our work, as well as focusing on other parts of the project, such as education, that this podcast is hopefully getting towards. By the end of the summer, we'll have worked on our wiki page, and that will be accessible to everyone so they can see our progress. We'll then work on going to the Jamboree, in which we'll present our ideas to a bunch of really exciting people. So that's the plan for the summer, and just a little bit beyond.
In addition, we had a question that came to us over the email. This question asked why we're using Receptor cells instead of BL21DE3 cells. So the reason we're using Receptor cells instead of BL21 cells is because Receptor overexpresses the tRNA and the tRNA synthetases. That will help produce more alanine needed for the MAST genes. And these MAST genes creates tensile strength and elasticity for our silk, which is what we're using for our end product.
Now that we've got through those questions, let's move on to our brilliant interviewer. So I'll let our lovely guests introduce themselves today. We've got iGEM Vienna on the line.
Hi, my name is Tatiana. I am the team leader of iGEM Boku Vienna.
I'm Julia. I'm mainly the lab responsible person from our team.
She's the lab team leader. We're an overgraduate team, largely. We have only a couple of undergraduates on our team. We both are students of biotechnology at the University of Natural Resources. And our project is now running on the track for climate crisis. And what it does, it sets out to make bricks that ideally cause a net reduction in atmospheric carbon dioxide. And the production is based basically on activity of two microorganisms. That's a cyanobacterium named Synecocystis, PCC6803, but I will not repeat it again.
Oh, that sounds exciting right there.
And the yeast Pichia pastoris. So cyanobacteria have a very cool ability that they have by nature. They take CO2 from air and then can use it in a process that we will generally term biomineralization. It is a very general term that describes its ability to take the CO2 and convert it into calcium carbonate, which is a solid mineral. And that you can basically imagine that these mineral deposits will be the solid part of our brick, but that needs some structure because these are small deposits. They're tiny because cyanobacteria are tiny. And for the structure is where our yeast comes in. In our lab, we work with Pichia pastoris. Our principal investigator is very experienced in it. And the strain of Pichia pastoris that we use also has a carbon fixation ability. They take CO2 to grow more. So that's also a plus. And what the yeast will do is it's a very well-researched expression organism. We will use it to produce certain proteins that will give our brick structure. Some of them are rather common, like gelatin. Some of them are rather obscure, like spider silk. And we will see what of these proteins helps us to do like good structural properties for our bricks. And thus, ideally, with the cooperation of these two organisms, we get negative CO2 emission bricks.
We actually started working with our first strain of cyano, but we only started like this week. So from next week on, we should have results on which concentrations and pH is the best for the production. Then we will continue with 2 other strains of cyano, but we're still in the process of cultivating them. They are a little more difficult to cultivate than the one we use primarily.
What makes them more difficult to cultivate?
First of all, the way we got them is we didn't have a liquid culture to start with, so it's always easier to have a liquid culture to start with. And we only had them plated out, so it takes a lot longer. Cyanos take a long time to grow. And one of our cultures, we're not sure yet, it isn't growing at all, and we have not found out yet why. So we will see. It's one strain that just doesn't work yet.
The background on those strains is actually quite interesting because we contacted an expert in cyanobacteria and we asked him for different strains that he could suggest. And as a side venture of our project, wanted to see whether we can combine these two, so like producing proteins and the biomineralization in one cyanobacterium. And those other strains that he sent, he was very gracious and sent us his strains. He said that they might work better for this kind of dual production system. However, we are personally not extremely familiar with those strains, and that will take a bit of time to get used to.
What were the motivations towards producing this?
As you know very well, that iGEM's kind of goal is to solve local and international problems using synthetic biology. And in our group, we went through various presentations, and there is nothing more local and international at the same time than climate change. And so that was kind of a good motivating factor. And after a bit of research, we were actually staggered to find out that an entire 11% of worldwide CO2 emissions can be attributed to the production of building materials. And the interesting thing about our concept, while we concentrate on a brick, and that the reason for that is that there is an inspirational paper that we are leaning on from 2020 that uses this biomineralization to make bricks, but they use only commercial products as additives. What we wanted to do is show that this is a great potential for zero carbon emission or negative carbon emission material for concrete or brick or anything really. And that was kind of the goal, to dent a bit the 11% that are there in the end.
That's a really, really interesting fact. I had no idea that construction materials were that bad.
Us neither until March.
That is staggering.
We actually had a bit of a fun moment. We had a presentation at a stakeholder meeting to see whether they would like to sponsor us or not. And after our presentation, where we mentioned it, and they are involved in manufacturing and building, and one of the guys at the meeting, he was looking at us after the presentation. He's like, yeah, I know 11%. We already feel bad enough about it, and we're like, we'll fix it. So it's apparently, it's a lot of people in Austria and I think worldwide are just not aware of how pressing that industry is.
Do you know if your project, the use of your bacteria, if it's carbon neutral or whether it's reducing carbon outputs?
That is actually part of our modeling strategy to a certain extent. We would like to see if we could upscale this kind of production. That would be a net negative or would just be neutral. Because the CO2 fixation would be kind of a one-to-one conversion, ideally. So it's kind of promising. If you can make an entire brick with calcium carbonate, that would be a lot of CO2. But you must also know that in upscaling, things can go quite haywire. So
just a little bit.
Just a bit. And but what is kind of interesting with our setup that I haven't really mentioned yet is that we kind of really wanted to focus on a very recycling center as well. There's 2 additives that we would like to try out in our brick material, and that's sand and mainly desert sand, because desert sand is unusable for in current construction because it's round and it doesn't really affix in for certain properties. And lignin, which is a waste product of the paper and pulp industry, which is largely unused, but just an also very promising biopolymer. And we would like to add it to our mixtures and see whether it contributes, whether it improves properties, and whether we could use it as well.
Really cool. Why have you chosen these biopolymers?
Gelatin is used in the original paper. And then we had a couple of meetings as a team where people got to present the materials that they would like to try. And spider silk is just very cool.
Yeah. Well, as we can affirm to that, spider silk is incredible.
It's insane, and also to make it is kind of wild. Julia also, when we separated our lab group in 2 groups, one that's responsible for yeast and one's responsible for the cyanos. And while the cyanobacteria are not expressing anything, Julia, on my end, while we were distributing, insisted that they will take the spider silk.
It was good we did, because gelatin and spider silk, they turn out to be like really complicated to get some plasmids out of them. And this is why we were actually happy that we split those 2 up as well.
It's a complicated structure, but it's fun to work with.
Yeah.
So spider silk is not commonly used in building materials. What's the hopes of adding it? What do you aspire for it to perform as?
In general, all the biopolymers are there to cross-link our structure. They're there to create a certain type of kind of like hydrogel stabilizing structure for the bricks, so we can pour our mixture and we have a brick after a certain amount of drying. However, with spider silk, first of all, it's a very interesting, very promising material. In general, different material industries and material chemistry, it's an interesting challenge to approach, especially in like the field of expression for different microorganisms. And there is such variety in the types of spider silk that, for example, in the case of piriform spider silk, we would like to concentrate on its ability to be like glue. But in major spider silk, we would like to take its stability in comparison to the other. So we would like to see whether the properties can be even used in such a way, because so far we see spider silk associated in clothing, which makes logical sense. But there are cross links that can be done on a molecular level that I feel like are unexplored.
So what led you? What sort of prompted you to look at construction materials?
Actually, it's one of our colleagues, Paula. She pitched the paper from 2020 that then we used as an inspiration, as a possibility. And we were very lucky that one of our current postdocs actually has extensive experience with cyanos, and he works with them. So we were hoping to lean on his expertise, and he's very helpful. And with the yeast expertise that we already have in the lab, that was pretty much a no-brainer. After popular vote decided, and that's what we're doing.
So how many people are in your team how many were voting on this idea?
We have a total of 11 people currently, and we have around 6 to 7 people in the wet lab. Everybody else is in other fields like modeling and collaborations and other things. And I'm trying to be everywhere at once. So that's the fate of the team leader.
See, it's funny because our team, we've got a team of 8.
Yeah.
And we don't have any kind of team leader role. How are you finding a team in which you have a leader and sub-leaders, obviously, because we've got our lovely lab leader as well here? How are you finding that?
I think it's actually really nice to have a team leader who feels responsible to check in with all the people, who have the overview of what is happening everywhere and who do I need to contact to get this. And if something does not work as well, you can always like go to Tatjana and ask her if another team maybe already worked with that or had similar problems or stuff like this. So I think actually it helps a lot to have a team leader who's like the responsible person you can go to if you need anything.
If somebody who's listening is listening to think about how to structure their future iGEM team, in case somebody wants to go to lab work, don't take the team leader role. You will not see the lab ever, because there will be too much to do. But it's still quite interesting work because I got to do a multitude of things that are very much outside of my field of study.
Yeah. Also, I think in the beginning we had a lot of problem with like we discussed something and then everyone had new ideas to it and stuff like this. And sometimes we just like needed this one person who like put her foot down and she said, okay, and now we're doing this and we don't do this. Because it was just like an endless discussion and nothing was ever decided.
Somebody has to be the unpopular one.
Yeah.
And
basically.
And that's just how it is.
Yeah, you don't all be running around like headless chickens. You need like some organization, like otherwise you're gonna be like, am I in the lab today? Am I doing collaboration? Who's doing human practice? What's going on?
I mean, it's funny because we don't have a leader, but Eric, you're the unpopular. No.
We didn't even choose actively.
No.
Cut that out.
Dang.
And how do you find trying to lead the lab team? Is it all quite cohesive, or are there decisions that have to be made in that aspect?
Well, the thing is, in the lab, we kind of have to make decisions on a daily basis because, like, usually if you do an experiment, it can work perfectly, but most times it doesn't work that perfectly, and you have to see, okay, what do I have? How can I get to this? We often have to make decisions. Okay, this doesn't work this way. Is there another way we could try? And it's always really helpful actually to have like 3-4 people talk it out, think about it together. They have more ideas. I think as soon as we get a little more than 3 or 4 people, it already gets like a little confusing because someone doesn't understand at which point we are or something like this. This is also the reason why we decided to do the lab team in 2 different groups. So we have like 3 people are responsible for this and 3 people are responsible for that. And if there's anything that needs to be discussed between the groups, we're always in the same lab, so we can discuss it anyways. But I think it's the easiest to discuss it in small groups, especially for the smaller decisions about stuff that didn't work the way we wanted it to.
Since the lab can get so hectic and iGEM itself can get so hectic, are there like any like crazy or funny experiences that have happened over like the past couple of weeks and doing iGEM?
Well, actually, we had to move labs. This was like really crazy because our lab wasn't free when we started lab work, and we had one lab and we started there, and then everyone had to move, and it was completely chaotic.
It was pandemonium.
Yes, but we are really happy with our new lab, and I think
great.
Very important is to have a nice and clear organization in the lab. Where is it allowed to do what is done where, what is done how.
I think if I had to give, when it comes to lab or generally, I think advice to other iGEM teams, future iGEM teams, current iGEM teams, document everything and in like the most minuscule way possible. If you think it's too much detail, it's not too much detail. If you feel like you need to, if you feel like it's kind of dumb to put a marker sign, this is the PCR place on the bench, and then glue it to it, and then just write clean the place up after you use it and all of that. And this is the general workspace, and this is where we put all the things that we get from sponsors and all of that. And if it feels like too much effort, it's not too much effort. It's gonna save you a ton of time when it comes to how
really
hectic
true.
iGEM just gets. Because
it's hilarious coming back into the lab after a few days of doing other things and then seeing what's going on? What's happening here? Nothing's noted down. It's super important, as you've said, to just put everything in a book, put everything online.
Yeah, like you're all saying, is labeling your stuff in the lab is so important. Like the other day, me and Lucy were in the lab, and we forgot to label the E. coli, and we balanced it in the centrifuge with water. So it span. We didn't know which number was what. So we had water and E. coli. They both exactly the same, and then we had to do a complete other. It took us an hour to measure the concentration, so we could figure out which one was water and which one was the E. coli.
Please label your things, people.
Yeah. Yes, and we had the same problem. Not exactly the same, but we had similar problems.
In general, Julia and I actually we worked together before in another lab, just as students. So this is why when we looked for a lab manager, I was like, I know that she does her work well, so I'm fine with her doing this, and I know that I can trust her in saying things. But even in working together and working on the same projects or similar projects, you kind of see that everybody kind of has their own handwriting in the lab. What I mean is everybody works in their own unique way in the lab. And what is important for lab management in iGEM, super important, is to keep it as uniform as possible. Everybody can retain their uniqueness in the lab, but if I label everything with my initials and what it is, and with shorthands that I know, but nobody else in the lab knows, it's ineffective. Or if I know people in colleagues of mine that label PCRs as just 1, 2, 3, 4, 5, great if it works for you. Doesn't work if somebody else looks at it later and has no clue what you did.
Wow.
So just be mindful, make an Excel table with all the shorthands that everybody will use, and then stick to it and force everybody to stick to it.
We have one of our team members, Lucy, whose last name begins with a B, meaning her initials are LB, which is obviously the broth that we use, the broth that we use to grow E. coli in. So during one of our experiments, we had a plate that was labeled LB, and one of our PIs came along and went, "This has just been labeled LB. I don't know what this is." And poor Lucy had to raise her hand and go, "It's mine. It's my name." That's all we have time for today, but be sure to check out part 2 where we continue to interview iGEM Vienna. In the meantime, why not follow us on Instagram at exeter.igem2022, on YouTube at Exeter iGEM 2022, or pop us an email on exeter.igem2022@gmail.com. Please ask any questions via the social media, comments, or the email, and any feedback is greatly appreciated. Bye for now.